welcome everyone to the next in Bernd Sheehan's Tales in Tech webinar series. We've been running these in the absence of being able to do more natural or not normal face-to-face meetups. So we're trying to fill a void in which I guess our tech community and our tech network can connect and learn from others and pick up ideas from others and what other individuals in the same industry are doing in their teams at the moment, what sort of solutions they're delivering. We've had a great reaction to this from our network and the community around us. So we're keen to keep running these webinars and we're keen to keep doing them. So if you've got any ideas or about things that you want to learn about, or if you yourself are wanting to do a webinar with us, please reach out, send the ideas to myself, to one of the team, to Becca, who's our community manager, and we'll hopefully be able to provide that sort of information and help you get yourself out there. Today's webinar is going to be with Matt Williams, who is a good contact of ours. He's an automation tester over within Residently in Manchester, and his topic is going to be data-driven test maintenance today. Before I pass you over to Matt and get out of his way, just want to remind everyone, if you've got questions as we go along, please put them into the Q&A function, and what we'll do is at the end, when Matt's wrapping up, when Matt's finishing, we'll run through those questions and get anything answered that you might have. But I'll get out of the way, but thanks for joining us today, Matt. I'll let you introduce yourself and get yourself going.
Yeah, thanks, Chris. I'll share my screen and say hi to everyone. Thank you to Becca for sorting this out as well. Here we go. Okay, so it's me. This is my little Twitter handle. I'm going to mention that again. If you want to get in touch later, feel free to, or send me any questions that you think of. Feel free to do that. So first, we're going to do some grounding about what this talk's about and who I am and why you would listen to me. So who am I? I'm Matt. I've done loads of different things. I've got a master's in astrophysics. I did some teaching for a while. I played music as a job for a while, like an actual job that paid money, which was weird, but great. And I've done loads of different roles in software teams, from testing to product analysis and business analysis type stuff to software engineering, which is where I do now. I work at Residently. We're a property tech startup in Manchester, and we're trying to make renting not absolutely abysmal like it seems to be at the moment. So I think like a good measure of this is it takes about 28 days on average to like go from being interested in a flat to having it as yours, and it's awful like all along the way, and our average is about 4 days, and I think the fastest is about 14 minutes. So we're trying to make it a bit better and a bit less hassle. So that's who I am. What's the point of this talk? That's a good question. So today we're going to learn how to use some data to improve the state of our continuous integration tests, or any tests you run, really. But I'm really targeting like a test that run in a pipeline. And we're going to go through a sort of simple exercise, well, not an exercise, an example setup, and we can step through like each of the core concepts and then get our head around them, and then maybe you guys can go off and actually use this in your real setups. So we'll start at continuous integration. I think, well, I hope most modern software teams use continuous integration to run their tests, and when there's new code, make sure everything's all good, and then merge it into the larger set of code. So I think if you do that and you live in that world, you have to accept that this these little ticks rule your life, and it's just easier just to give in and accept it, that you're a slave to these little ticks, and everything is better once you accept that. And it's a good thing because they help us keep quality high. So I'm going to assert that the reason we're doing this is because we're striving for the smallest feedback loops possible. And it's the same with Agile development in general. We don't want to let something get all the way into production and wait for a long time before we realize something's wrong. We want to realize something's wrong as soon as possible. Like if we could know straight away after we've written a test, that would be, or written a new piece of code, that would be like the ideal. But normally, we're somewhere between like instant and just after deployment. So when we do this, like often stuff fails, and that's a good thing. Things should fail because that is us getting our feedback, and we can go and check that something's not wrong and it doesn't get to production. So sometimes they fail and they shouldn't fail though. Sometimes they fail and something isn't right because we've also written these tests and there's things that we have to maintain, and not always perfect, just as we're not always perfect at testing either. So this is a diagram that we're going to use to build on for the rest of this this talk. So if we look in our top left green box, we've got tests that passed and tests that should have passed. So if they should have passed and they did pass, then happy days. Everything's good, and we can move on with life. We can start deploying stuff. In the other green box, we've got tests that failed when they should have failed. And that's also good because we're getting the feedback that we want, and we can go and fix them early. And that's the point of what we have continuous integration for. So that's good. And what we're going to focus on in this talk are the two red boxes. So the top right one, tests that failed, but they really should have passed. These are normally called like flaky tests. And, they're everywhere. Every team has some of these. You just got to keep on top of them and try and figure out what you can do to make them a bit less flaky. And in the bottom left, we've got tests that passed, but they really should have failed. And these are even worse because normally they're a lot harder to catch. You might not necessarily know that they've even should have failed. So we're going to try and, first of all, just identify that we have some of these tests, and then we've got to do the actual hard work of fixing them. This talk is mostly focused on how do we identify those ones that we should focus on and spend some time fixing. So, go to the next slide. Why are these flaky tests bad? I think it's important to go through before we move on to how we do it. The first one is because it adds time to our development cycle, and that's a pretty obvious one. Every time something fails when it shouldn't have failed, or something passes when it shouldn't have passed, then we add time to building new stuff, which nobody wants. We want this to be as quick and easy as possible, and each little failure adds time. The second one's a bit more serious, and it's about like breeding distrust in your tests, and this isn't a good place to be in either. Unless you trust those tests are doing their job, they're not much use to you, because if they run and people don't trust that they're doing what they're doing, then they're just going to test it again, or they're just not going to test it and accept that they have a product or a service that is of poor quality. So that's not good in either scenario. And like lastly, they can also feed distrust in the actual thing that you're building. Like if they result in bugs getting through to the production version, then and users start using it and coming across them, if that keeps going, it's not going to go very well, for the users and for the feedback that you get about the product. Also, people internally are going to, if everyone sort of blames tests all the time for slowing things down, then people who are outside the software development part of the business, who might not understand the technical side, are going to start to think, like, what's the point of this? Why are we spending time doing this? That's also not good for anyone. So if we all agree with those, which hopefully we do, we're going to move on and see how we can get the things in the red box to move over to whatever green box they should be. If they should fail, they should fail. If they should pass, then they should pass. So the first step in here is to identify the ones that are causing us a headache. So we've got to define our problems first. We're going to use some better language than flaky and surprises, and we're going to lean on the probability world. So flaky tests are ones that failed when they should have passed. So we call these false negatives. And you might find it easier to think of it a bit backwards. They were negative, but they shouldn't have been. And the same for surprises. We'll call these false positives because they were positive, but they shouldn't have been. So these are the two big ones that we're going to target. And we need to be able to measure these things somehow. We need to be able to get something we can measure to target and label something as one of these false positives or false negatives. So we're going to define these three measures. Something's a false positive if it runs and passes, the test runs and passes, but then it fails on the same commit, or it fails on the same bit of code. That means that nothing's changed, but it's failed after it's passed. And the same but opposite for false negatives. If something runs and fails, but nothing's changed, then the first result must have been a false negative. The last bunch I'm going to throw in is the long-running tests, because our core tenet of this was that we're doing this to reduce our feedback cycles, and we're doing this to ship more stuff faster. So long-running tests are really bad because they often don't need to be long-running. They're even worse if they run slowly sometimes, but we're not sure why, because that indicates that something's going wrong or something isn't consistent. So I'm going to throw that in as the third measure. It's also the easiest one to look for. So it's going to be a nice intro. So the rest of this talk, we're going to figure out how to find these. First, we're going to look at the example that we're going to go through. It's called Pipeline Stats, which is just a working title for this talk, but there's a website called Pipeline Stats. Let's look at it. This is it. It's a real website. It doesn't really do much. It's got some pages that are readmes for stuff on GitHub that I just pulled at the time. They don't really do anything. There's some other pages, but it's a simple example site that we can look at. So in order to get a new version of the website, there's a little pipeline, a little continuous deployment pipeline that runs. And here they are. I'm using GitLab just because I like it, but you can use whatever you want. GitHub, what's the Atlassian one? Bitbucket, if you really have to use that. And we've got 3 stages. We build the stuff for the website, we run the tests, and then if the tests pass, we deploy the website, and everything changes. And there's a bunch of these that run every time something happens. And I've also run some on a schedule so we can get some more data. So that's what we're looking at. Pipeline Stats, little website. what does this do? This is the first important bit. When we run the tests, we export the test results into a machine readable format. So we're using a JUnit format, which some people might be familiar with. There are loads of formats for this. JUnit has just been around forever, so I knew that there would be loads of libraries I could use to do this for me without doing any work. And I love not doing work. So let's have a look at what this looks like. It gives us a bunch of horrible XML, but that doesn't matter because there is a load of libraries that are going to help me do this anyway. So let's have a look. Here's one of our tests that passed. We run some end-to-end tests. And when we do this, it gives us some artifacts, some stuff that comes out the end. Cypress gives us some videos. We just have a look at one of them to see what it's doing. This is one of the tests. It goes to the home page and it checks that there's some posts there, and it goes to the next page, and gives us a little video of it doing that, which is great. It's really quick. So there you go. It did a load of stuff, and alongside all that, it outputs some machine readable results. And these are our XML files that have information about the tests in. So this is where we're getting our data from. So let's just recap this briefly. We get some new code, we create a new pipeline, we build some stuff for the website, we test it. If the test pass, we deploy that to the new website version. And when we run the tests, if they pass or they fail, we dump some results and we dump some videos in a big bucket of artifacts. So what we're going to do now is we're going to look at all those pipelines that run and all the artifacts that get dumped in the bucket. And we're just going to use Python to run some analysis and make some nice, pretty graphs that are also really useful for understanding what problems we have. If you don't use Python, doesn't matter. You can do this in any language you want. It's pretty easy to read, and we're just going to go through stuff anyway. You don't have to understand every little thing about it. So the first bit we've got to do is download some data. This isn't like the most exciting bit, so we're just going to run through this. I'm actually going to do it all though, so we can see it going. So this is just using the API for GitLab, and there's a nice like Python library for this. This is going to be true of like most of the big players, like GitHub has one, like any other little hosted version system you might want is probably going to have one. And if they don't have one, they're almost definitely going to have a HTTP API. So you could do that if you wanted to. And they're almost certainly going to have a library like this in any language that you might want to write this in. So we're just downloading the last 100 jobs that were a test job, and let's save them. Next, we're going to make a new directory for today's results. So there'll be one at data/7th of July. And then we're going to download all of those artifacts. And this really doesn't take that long. It is actually doing it right now. We can watch it churning through here. It's just downloading a load of stuff and then unzipping them and putting all the reports into a folder. It will finish in a few seconds, and then we can move on to doing some more interesting stuff with all that data we just got. But I'm running this so you guys can see, like, we did 100 jobs. However long your pipeline takes, it probably outputs a bunch of stuff, but it really doesn't take that long to run one of these, and you can just do them ad hoc. Right, so that's done. The next thing we're doing is we're using a parser to read those files that we output before and get some of the data out of them. And this is one of the reasons why I use JUnit, because I knew I could just type in JUnit parser and there's going to be one for me already. And there was this one. I've never used this before and it was fine. It just did its job very well. But this is the second important part of our journey. First, we output machine readable data about our tests, and now we're reading it again so we can do some useful stuff with all that information. So great. And we're ready to like do some interesting stuff with it. We've got all the data that we need. So our first thing that we're targeting is long-running tests. This was the third one, but the easiest one. We're going to go up the list because it works. They're roughly in order of severity and also difficulty. So let's have a look at long-running tests. We're just we're going to get all the reports, and then eventually we're going to get all of the test cases out of the reports, and we're going to plot the name of the reports against the time that they took to run. So we can do that there. That's really easy. And next we're going to make a nice graph. So pandas is a nice library for Python. If you haven't used it, it helps you do data analysis. That's not super important. What is important is this one, Plotly. Plotly is a library that lets you make really nice graphs. Express is their version of a lazy man's library. It just does everything for you and it's excellent. I can highly recommend it. Here we are making a data frame, which is just a table essentially from all of our durations that we had, and we're plotting a scatter diagram. So let's have a look at it. Here we go. Here's a nice diagram. It's interactive. We can zoom in if we want to. We can do loads of stuff. Everything's great. So we got 3 tests. Yeah, it's a small website, and this is just an example. In real life, you likely got hundreds of these, and you can start filtering ones out if they don't take more than whatever seconds. You can manipulate this however long you want, and it's very, very easy. So the important thing is we can start looking at this graph. Now, this one down at the bottom, the home page should display the recent posts. Well, that looks pretty good because it takes about 1.5 seconds, and there's a bit of a spread. Sometimes it takes 1 second, sometimes it takes 2 seconds. There's some weird ones, but there's always going to be 1 or 2 weird ones. But that's quite consistent, and that's good. These 2 are not good. This one takes 4 seconds sometimes. Sometimes it takes 3 seconds. And a lot of the time, it only takes like 1 second. So this is a red flag for our long durations, and only sometimes measure that we're trying to use. The top one is as well. This is a great way to pick out, these 2 are obviously not good. Sometimes they're taking really long and we don't know why. So we've already identified 2 of our tests that we might want to go and investigate. These ones are long and they're only long sometimes. So that's great. We've done number 1 out of 3. And it took about 10 seconds. So happy days. Next, we're going to move on to the false negative tests. So false negatives, the ones that run and fail, but then they pass again. These are annoying, and sometimes you call them flaky tests. We're calling them false negatives. You often get developers saying end-to-end tests are always flaky. Don't believe the hype. They're not. You've just got a bad test. And this is a good way to identify which tests aren't so good and you can work on. So this one's a bit more complicated, but looks like last time we got the name of the test and we got the duration. Now we're getting a bit more information. We're making, for each one of these things, we're making a bunch of bunch of entries that have information about the commit, when the job ran, whether it passed or failed, how many times it failed, or how many tests failed in that suite, and when it ran. And again, we're making a data frame, and we're just filtering out any tests that didn't run any suites that didn't run any tests, sorry. So we make our new data frame with all that information. And we're going to do another plot. Oh, look at that. We don't want that one. It's going to look a lot better than that. This time we're going to do a line graph, because this one's more about things changing over time. And we're also going to add this thing in that tells us for every commit, how did things change? So let's have a look at what this ends up as. So we've got lots of little rows here. These are blue sections. These are all the different commits. And along the left, these lines are saying how many failures there were in that test suite. So red, which is about the about page suite, that's really good. There's no failures. It's really consistent over time. Everyone's happy. Every time this runs, there's no failures. But the blue, the home page, this looks pretty dodgy. There's one failure and then it goes back to passing again. It's done the same here. And this is an excellent marker for what we're trying to look for. Tests that fail, but then pass afterwards. That's not a good thing, and that is our false negative tests. So we've done 2 out of 3, and that really didn't take much extra work either. So let's move on to the last one. False positives. Now, these are when a test runs and it passes, but then it fails again on the same commit. And these are much, much harder to catch for a couple of reasons. First one is, why would you run a test again after it passes? Normally what happens is someone runs a test and then they get a big green tick because they all passed. Well, they move on with life. They don't run the test again. So you're not likely to get much data on this. Number 2 is, even if you do get that data, sometimes they can look like false negatives. So in the pipelines that we're running, or that I'm running, I've been running them on a schedule, so we can get a bit more data. And if we look at our graph again, let's just update this one. If we look at our graph again, we can see that I've been running them for a while, and these ones look like false negatives, like they failed, but then they're passing again. But these ones are more complicated. Maybe they're false negatives, maybe they should be passing, or maybe they're just really, really bad tests and they should be failing, but they're passing all the time, or a lot of the time. And this can make it quite complicated to identify which ones are false negatives, which ones are false positives. But the important thing here is it doesn't really matter which one, if it's false positive or false negative, there's definitely something wrong with them. So we still have to go in and look at the test. We still have to identify why they're failing. We have to do that anyway. The important thing is that we've got a way to identify some of the ones that we want to focus on. Okay, so there's quite a lot of stuff there. We went through fairly quickly. And let's just go through a little summary to see what we did. So we had our 3 things that we were looking for: the long-running tests, the false negative tests, and the false positive tests. And we developed measures to work out which one of our test cases or test suites fit into each of these buckets. Then we did a bunch of different steps. We created some test reports that a machine could parse with a JUnit reporter. We downloaded them. We parsed the reports that we downloaded. Then we arranged them all into data frames or tables. And then we used a nice library to plot them. And then we could just look at our graphs and we could identify with our eyes how each test was measuring up to our measures. So there are absolutely loads of things you could do from here, and loads of things you'd want to do if it was a more complicated test environment, but the basics are still the same. These are the steps that you would do pretty much every time to work out which one of your tests you want to spend time on, which ones don't matter and are working well enough. As some ideas of things that I haven't put in this sort of intro talk, we have to look at these graphs every time and spend time on it. You could absolutely identify them and get something to notify you if tests are looking shady. That's more than doable, and all that takes is running another couple lines on the data frame that we've already created. You could also do some more trend things over time, or identify when things are about to go badly. But we won't go into any of that. We'll just leave that as a sort of ideas thing. And we'll just wrap up with some final sort of advice and things that you might take away from this. So the first one is, if you think you might have a problem with some tests, run them a lot and get all this data, especially if you think you might have some of the false positive tests where they are passing but they shouldn't be passing. You're likely not going to get that data unless you run them a lot. I'd suggest run them overnight a few times every night, and just send all of these reports into a bucket where you can download them later. The second bit is, if you don't write Python, if you don't have a good background with looking at graphs or interacting with APIs, it doesn't matter. There is a flavor of this for everyone, and just use whatever tool you want to use. You can accomplish the same thing. And lastly, you can absolutely get all this code. I haven't put it in a repository or anything, but if you tweet me and mention this talk and mention Ben Sheehan for doing such a nice job of putting this on, I'm more than happy to send it over to anyone who wants it, or even just wants it to spark discussion about something else. So that is absolutely fine. I hope that has sort of sparked some ideas for people, or opened some doors for some people who are having problems. That is pretty much the end of my talk.
Awesome. Cheers for that, Matt. Really appreciate it. Thanks for the effort of showing and talking us through that. Obviously, with regards to everyone watching, if you have any questions, please fire them through into the Q&A section. We did have one that was preemptively asked as well for you, Matt, and it's really kind of based, I guess, coming from more of a junior person, just asking for any advice really for junior testers or engineers to help build up a good career. Have you got anything that you could help sort of advice on that side of things?
Yeah, I think it definitely depends on what your interests are, and if you've not figured that out yet, then just try out loads of things. Try out everything that you hear anyone mention, even if it's not a test thing. Just do it anyway. Try writing some APIs. Try and build your own test stuff. Test harness or reporting system. Just give everything a go, and you'll find out what you want to do and what you enjoy doing, and then just keep doing more of that, because you'll probably be good at it if you enjoy doing it.
Good. Question that just come through: has this approach helped you efficiently re-establish confidence in your tests for those that have once written the tests off completely?
Well, the difficult part of that is re-establishing some trust. It's absolutely like once things work, normally people just, people expect things to work. They only make a fuss when they don't work. So if you fix them, that's really good. But it often takes you, explaining how much time they're wasting for people to take it seriously. But I would absolutely say that, yeah, you can run this sort of this concept against like big, small pipelines, and it'll work just as well. And you might find like you just don't have a problem, and that's also a good result. You might find you have a really bad problem, and if you have the graphs there to show everyone, it really goes like quite a long way into convincing people it's worth spending time on.
Great. Well, it's like we'll wrap it. Oh, sorry. The one's popped through, sorry. Just as I was about to wrap that one up, sorry. Any advice for new beginners getting into automation? Which tools to start with, i.e. Cypress, JavaScript, or any other recommendations?
If you're doing it at work, just go with whatever you can do at work, because practice is definitely key. If you can pick like anything you want to do in the world, and you just want to explore nice, fun stuff, then this this repo uses Cypress, and Cypress is great. It's really fun to write and run, and everything is like just easy. So I can definitely recommend Cypress. I think that's at cypress.io. This one's in JavaScript, so you have to learn a bit of JavaScript. I think if you're a beginner, like languages can be intimidating, but once you've picked up one, the next ones are a lot faster to do. So just like dive in, do some basic tutorials if you're not used to that, and you'll get there.
Good. Excellent. It looks like those are all the questions that have come through. I guess we'll wrap it up there now. I'm guessing nothing else jumps in the last second there, but just wanted to say thanks, Matt, for doing that. Really appreciate it, and thanks for everyone who joined us. We had a really good turnout. If you've got any questions, like I say, Matt, I'm sure happy to answer them. Or with regards to Burn Sheehan as well, if you're wanting to hear something specific, or if you yourself want to talk, we're getting some really good numbers turning out, some good interaction from our community and from the network around us, really. And it'd be great to hear what you want to hear or what you want to talk about. Get in touch with myself. You can get me at chris.m@burnsheehan.co.uk or Chris McGowan on LinkedIn. And also Becca Rose as well, Becca@burnsheehan.co.uk. Reach out to us and we'll set these up, and hopefully our community will benefit from that. So really appreciate it. Thanks for everyone. I'll let you all go enjoy your evenings, and hopefully tune in for our next talk. Thanks a lot.